So the talk will be about monolith or microservices designing deploy time flexibility for modular systems, which is very interesting. As a backend engineer, when I'm doing interviews, describe monolith versus microservices is one of the go-to questions I ask. And well, I guess we will hear a really long answer for this. Usually we don't have time for that, but now we do. So let me introduce you Florin Coros, who will talk about this for you. And if you have any questions, use Slido or raise your hands, then I can hand you the mic. Please give a round of applause for Florin.
Thank you. Thank you for the introduction. How was your conference so far? Great one, right? It's one of my favorites, and I have come with a lot of enthusiasm here. I want to start with a big thank you to the organizers and to the sponsors for putting it up together. Thank you, guys. The title of my talk has the subtitle in bold, and that's on purpose. Because the core of our discussion today is not going to be that much about monoliths or microservices, but I will show you a solution which allows you to decide only at the deploy time. So after you have written the code, compiled the code, only after that, you could decide if your modular system should be deployed as a monolith. And in that case, the communication between your services will be just simple function calls. Or if you'd want, you could take the same code without recompiling and have a distributed deployment like microservices, and the services will start to communicate through REST or gRPC or a message bus. And I'm going to show a demo on how this works. In the demo, I'm going to use REST, because that's maybe the easiest to have some communication. And in the demo, we'll see a distributed deployment, and then we are just going to copy some binaries from one folder to the other. And as previously, things were communicating through REST, and after we do that copying of DLLs, things will start to communicate through simple function calls. I'm happy that we have quite a lot of time today, like over 100 minutes. So I could really go into the details to show how this was built. Because when I do this demo in a shorter session, like 45 minutes, it feels very, very magical, and people don't really understand what's happening under the hood. And you'll see there is no black magic. It's just simple programming. You just need some reflection and some dependency injection. I'm doing it in .NET, but the same can be achieved in Java, TypeScript, as long as you have interfaces and a little bit of reflection, things can be done. And the power of it is mainly the structure and the design. Before we go into it, I will introduce myself. My name is Florin Coros. I'm coming from Transylvania. And I just learned that my name has some Hungarian roots. So it's my father comes from an area where there are many Hungarians. So it's very nice that I can come easily towards here to Budapest. I am the founder of CoDesign. We are a small company which focuses only on the design part from software development. And we do this by two types of activities. On one hand, we take over the role of the architect or solution architect in the clients, in the projects of our clients, and we lead the process, the design, and the implementation. So we try to put a project on a path to meet all its goals on budget and time. And the other set of activities that we are doing is training on software design topics. You can find more about myself if you just follow me on LinkedIn or if you browse our company website. With this out of the way, let's dive into the technical stuff for today. And I would like to start with a discussion about a monolith. How many of you work with a monolith or have worked in the past? Just almost everybody. I will admit that I love working with a monolith, because the first thing that comes in mind when I look at that big thing is that life is easy, especially now that I know how it is with the microservices. With a monolith, you have everything in one place. One repository, you clone it locally, hit F5, everything builds on your machine, and then you can easily debug and see what's going on. However, having this big thing, monoliths are not that good at certain aspects. And if maybe 15, 18 years ago, it was like the way of doing things, the monolith architecture, or we were having probably like a three-tier architecture. So you had the client running in a browser, you had the backend, which was itself a monolith, and then the database. And this was the way of doing things many years ago. We realized, and we started to move away from the monolith because of it, that we realized that monoliths are not that good at scalability. That's maybe the first thing that comes into mind when you're thinking where the monolith is not good. And you could probably scale a monolith, meaning that you make another instance of the entire thing. But with monoliths, it's always all or nothing. You cannot take a small piece of it, scale it more than the other parts. So it's not really feasible, it's not really cost-effective to just create another instance of the entire big thing. And even if you would do it, you still have to synchronize the state among them, which is quite tricky to achieve. There are other things where the monoliths are not that good. I need a pointer because, okay. For instance, reliability, availability, resilience. Those are other aspects where monoliths do not shine. Imagine that you're having multiple users working at the same time in your monolith system. Let's say you have 50 users only. And only one of them, opens a screen which has a bug, null pointer exception. That thing will blow up the entire system. All the users will be affected at that moment. So it's not really good for reliability. Resilience is not easy to achieve because you can't really restart it in an easy manner. So most of these things in the first column here on my slide could be solved with some level of redundancy. Now, the monoliths have other downsides as well: maintainability, testability. And when you think about a monolith, many times you remember those huge code bases with a high coupling, which makes things to be difficult to be changed. There are those systems that are rigid, fragile, you're changing something over here, that change triggers other two changes, and you're finding yourself running for changes. So bad maintainability, and many times bad testability as well, because with a monolith, you need, in many cases, to test it end-to-end. You can't really test in isolation in an easy manner. So most of these things on the right are because we don't have a good decomposition in our system. Modernization is another thing where monoliths are not that good. You can't, again, it's all or nothing. You can't take a little piece of it and rewrite it in a different language or technology. And this reminds me of a story which happened to me maybe 11 years ago. I was visiting at that time with a company that I was working for, prospect, a potential client. It was a bank in the Netherlands. And these guys were into investment bank. So they were doing a lot of financial trading. And we were in a workshop with them to see if we can help with their modernization effort. We realized in that workshop that they were at the end of a huge effort to split their monolith. It was like 3 years they worked to split their monolith into more pieces. And they had two main drivers for this effort. The first was modernization. They needed to migrate the system from Delphi into C#. And the reason behind it was that it was harder and harder for them to find good developers in Delphi, so they had to migrate to something else, and decided C#. And they couldn't just rewrite the entire thing at once in C#. So they said, first we need to split it into smaller pieces, and then rewrite pieces one by one. They couldn't just close the bank for a couple of years to rewrite everything in C#. So this was one of the reasons. The other reason was the release cycle. They were able to make a release around once every 14 months, more than a year. This was huge even for 11 years ago. And the reason behind it was testability. They had to test everything at once, and they couldn't afford bugs because they were in investment trading. People were losing money at a very fast rate if they had bugs. So they had to do a lot of manual testing. And we realized in that workshop that they are at the end of this breaking the monolith into smaller pieces. And they did it after 3 years of work, and now they had a new problem, performance. It turned out that the new system, after they have split it in pieces, was running very slow in certain core use cases. They had behind of a user action like place an order, they had a call chain of about 10 to 15 hops. So one service calling another service, and so on. And the network latency was adding up to a high number. So the performance was not acceptable. So they have spent 3 years to split the monolith, and now the resulting system was not working correctly for the core use cases. They weren't that happy. And basically that was because of this poor performance. But when thinking about microservices architectures, complexity is mainly the first thing that comes into mind. They are much more complex. We have complex communication. You have to think about transactions, reliability, how do you communicate in a safe manner between your services over the wire. The development experience is no longer that nice and easy. You no longer have everything running on your machine in the same process. You might have different Docker containers, different technologies, different communication protocols. It's not that easy to debug things, to do diagnostics in production, so you need to have some logging that integrates everything at once. It's much more complex. And usually the infrastructure is, again, more complex because now, or more expensive, because now if we can deploy each service on its own machine, we are tempted to employ maybe an infrastructure that's maybe too expensive than needed. So many of the things with monoliths, with microservices fall in this category of unnecessary complexity. But still, in microservices architectures, we still have problems related to maintainability and testability. Testability this time is not maybe because you cannot test every piece in isolation. That's easier to do. But the challenge is now, how do we verify that everything works together correctly, producing the features that we want? So it's more like a problem into how you test the integration between the resulted pieces. And maintainability is now more because you're having a web of communication between different pieces, like what happens if I change this API? Who gets affected? Is this piece of code the correct? Does it have the right place in this service? What happens if I change it, and so on? So again, microservices suffer from a bad decomposition. And a couple years back, maybe 5 years back, we started to move away from the microservices, and we started to go back towards the monolith, and we call it modular monoliths. So it's like the history repeats itself. 15 years back, we moved away from the monoliths to the microservices. Now we are moving back towards the monolith, and we are going in this circle. Again, more or less having problems regarding the decomposition. I think we are moving in this circle mainly because we don't ask the correct question. Microservices or monoliths is not the right question to ask. What I think you all want to build is a modular system. This is what all the developers want to have, a modular system. Why? Because a modular system has these three attributes: maintainability, extensibility, and reusability. And it turns out that these three things, they come together. You cannot have one without the other. We are very often tempted to say that we only want maintainability. We don't care that much about extensibility or reusability, and I think we are doing it because it's harder to sell it to the management. It's harder to convince a manager that you want to invest in your design to make it reusable. Because what the manager hears is that someone else, another project, will benefit of our work. And that's not that important for this project. Manager will say, let's first finish this system and then think how we extend it. But in engineering, things don't work this way. You cannot, the more you work on extensibility and reusability, when you're trying to decompose your system, the more maintainability you will get. These three things are together. You cannot have one without the other. Yuval Lawi, the one from whom I learned a lot about modular systems, calls these three the stability. It emphasizes even more that they are together. So what we want with a modular system, we want to be able to work in this purple guy over here without the green to know about it, or at least to have a chance. With reusability, what we want is somehow to be able to unscrew the orange from the blue, throw it in a different system, and use the orange over there. Even more, it would be nice if we can bring in a yellow guy, screw it into the blue over here, have it to do the same things for the blue as the orange, without the blue to know about it. So the blue now gets the same features from another implementation. So basically, we are extending the system with another kind of behavior by replacing this orange guy with a yellow guy. Of course, we also want to have the possibility to add a pink circle over here, plug it in into the blue, plug it in into the green, and extend the system in this way. So the modular system is when you have this system that's built by separated things that work together to produce the features. Those could be modules or services. And you get the stability, maintainability, extensibility, and reusability. Another thing that it brings, more relevant for our talk today, is that it provides a separation of concerns in regards to communication. So you can separate the communication concern. And I believe that most of the monolithic architectures and the microservices architectures suffer of bad decomposition because when we think about the decomposition, we are also thinking about the communication and about the deployment. We too often think about will these two things live on the same server? How will these services communicate one with the other? And the communication shouldn't be our primary concern when we think about the decomposition. That should be something secondary, like a different thing we are going to approach at a later stage. So a modular system allows us to do this. Now, when we look to a modular system, another question is, how many services should we have? And to answer this, I'm bringing in a graph from the writing software book of Yuval Lawi. And this one shows the two things we are paying in software development. We are paying for the cost to build a service, that's with the blue line over here, and we are paying for the cost to integrate the services. So this graph shows the number of services by cost. There is really nothing else, the cost to build the service and the cost to integrate the services. That's pretty much what we are paying for. And we have here in this green, dotted green line, the sum of those two lines, the sum of the costs. So when we decompose the system, what we want to do is to bring it into the area of minimum cost, somewhere over here. We need to reach a good number of services, not too many, not too few, just the right number, so we are in the area of minimum cost. This is the mission in life of the architect. The architect has to decompose the system and to be in the area of minimum cost and to keep it there. Nothing else really matters. That's all it has to do. Now, when I'm saying in the area of minimum cost, I'm not saying it should be here at the center. Anywhere here is good enough. And the reason is that this effort of decomposition has a diminishing return. So if you're looking here, how much effort how much gain you will take by moving the number of services from here to here, it's very, very tiny in comparison with the same effort to increase the number of services over here, because these lines are not straight lines. Now, again, how many services should we have? Clearly, 1 is not a good number. Nobody wants to have a design with a system which is built with one big thing. Why? Because nobody knows how much it will take to build it and how much will it cost. It's astronomical. It's somewhere over here. At the same time, nobody wants to have a system like this, which is built by 1,000 of tiny little things or 1,000,000 of tiny little things. Why? Because nobody knows how much time it will take to build it, how much will it cost. It's astronomical, somewhere over here. So, how many services should we have? Let's think in orders of magnitude. 1 is not a good number. 100, again, not a good number. In orders of magnitude, it should be 10. Can it be 20? Yes. 25? Yes. 30? It's your system. Maybe. But clearly 90, not a good number. 2, not a good number. Somewhere around 20, 25, depending on the system. But for this to work, for this modular system to work, we really need those services to communicate through contracts only. So we really need to have good contracts as dependencies among our services, because if we don't, if we have dependencies through the implementations and so on, we are either here or here without knowing it. So for modular systems, contracts are really important. Contracts are key in a modular system design. So I want to have explicit contracts. Explicit contracts, in my world, means those contracts that have good abstractions and good encapsulations. I want a contract that describes what a service does, to do it in such a way that the client doesn't want to know how the implementation is done. That's abstraction. And even if the client would want to take a dependency on the implementation, it could not, because the implementation is hidden. That's encapsulation. This is what I want from my contracts. And if some of you have seen one of my webinars or have been to one of my training, you would recognize that diagram, that box that's written contracts there on top of it. That represents a contracts assembly. And I like to build in the projects that I design. I like to build a structure in code which supports or even enforces the key aspects of my design. And the contract assemblies are the ones that are supporting contracts in a modular system. So I have this physical boundary, like an assembly in .NET, like a package you would have in Java, which has a very strict rule. In this place, we can only write contracts. There is forbidden to write any logic. And by no logic, I mean no ifs, no fors, no Boolean expressions, no logical operators, nothing. Just interfaces. The interfaces describe the operation contracts, DTOs, which describe the data contracts, and maybe exceptions for the fault contracts. Nothing else is allowed to be written in these ones. So now, having a modular system, we can come back to see how we design for flexibility at deploy time. And coming back to the story with the investment bank that I told you at the beginning, what I proposed to those in that workshop to the investment bank was 11 years ago was something like this. I told them, look guys, what if you would be able to continue to move forward with the decomposition that you achieved? You spent like 3 years to break the monolith into subsystems. They didn't call it microservices at that time. They were calling them subsystems. They were communicating through a message bus, through TIPCO, if I remember correctly. So I said, OK, what if you would be able to continue to use that decomposition that you have? And then, if you find like 2 or 3 services which have a very intense communication in certain use cases, what if you would be able to take the binaries of those, deploy those services on the same server, in the same folder, load them in the same process, and have them communicate through simple function calls without network latency? You will be able to develop them, test them, as if they will always be deployed on their own, but just by changing the way you deploy, load them in the same process, have function calls. Of course, they liked the idea. It was exactly what they were needing. I built a POC that proved how things would work in their context. We won the project. The company I was working for managed to build a team of about 20 people in a couple of years. The investment bank had a good way forward, so it was a good solution for that situation. And that inspired the talk of today. So in the next part of the session, I'm going to show you how this gets built. And basically what we are going to do is to focus on this arrow over here, the communication between 2 services. Of course, one is going to be the client, the one that makes the call, and we have the service, the one that implements the function which is being called. When these 2 things are being loaded in the same process, that arrow represents a function call. That's it. But then, if the same two services are being loaded in different processes, that arrow represents a REST call. And to make it a bit more easier to follow, I'm making the example a bit more specific. So I'm taking 3 services inspired from the investment, from trading. And the key idea is to have some dependencies among them. So we have a quotation service over here. It has one function, get quotations. And then we have an orders service, which has 2 functions to place a sell limit order or a buy limit order, and one function to get all the orders which were placed. What's important is that the order service needs the quotation. So to be able to place limit order, you need to see what's the price of the securities. So there is this dependency. And then we have a portfolio service, which is able to calculate the value of my portfolio. And again, this one has a dependency on the quotation. So we have 3 services which depend one on the other. And what I will do in the demo is to play with these deployment configurations. We have here on my right the monolith deployment. That's like a modular monolith. The services will communicate between them in process, but we can do another deployment configuration, which is like a microservices deployment where the services will communicate through REST calls. So when someone over here makes a call to the order service, the order service will make a REST call to the quotation service. And the demo will basically start from the microservices deployment from here, which is, let's say, the highest distributed level. Each service is hosted in its own process. And then we are going to assume that there is a very intense communication between the orders service and the quotation service. In a real project, we would basically look through some metrics from production and see, okay, these 2 services are very chatty, and we have performance problems because of that. And then we could decide, okay, what if we place this in the same process and have that communication to be through function calls. Basically, if we would have here a client which would call these endpoints, let's say there are REST endpoints, the client would not be affected by changing this deployment configuration because the REST calls remain as they were. So basically, each of the process will expose through REST the services they have, but now when someone makes this call, the order service is able to make an in-process call over here. It's no longer a dependency at this point. So this is what I'm going to show in a minute. Now, this solution stands on 3 pillars. Of course, you need to have a modular system. You need to have dependencies only through contracts and a good decomposition. But there are these 3 pillars that make the solution work. First, we need dependencies only through contracts. And as I was saying, we are achieving this through the structure that we are putting in place. The second pillar are the proxies. So each contract will actually be implemented by a proxy. And the proxy will forward the call through REST, in our case, in another process, or in case that the real implementation is available, it will be another type of proxy which will forward the call to a class in the same process. And then the third pillar is type discovery, which allows us to implement a generic host. So we could have a host. In our demo, it will be just a console, which can host any service. And it needs type discovery because it needs to look what has been deployed when the process starts. Now, we have a training. It's called Application Infrastructure for Clean Architecture, which teaches how to apply all this. That training teaches you how to implement type discovery using a small library we have built. It's called Application Boot. And it also teaches you how to create this infrastructure in code that will support the separation that you want and the dependencies between your services. For the rest of the session, it's going to be more or less like a mini version of that training, because I'm going to show you how this demo is being built step by step. I'm not going to type all the code. I have a Git repo, which you are free to take it on your laptops. It's on GitHub. And in that Git repo, I have some tags, and I will walk you through each step on how it is built. So maybe before we run to the demo, if there are any questions until this part. That QR code is just my LinkedIn, so no worries. Do we have any questions up until now? If there are no questions, then I will just bring Visual Studio. Okay, here we go. So first, let's have a look on GitHub. So if you go on GitHub on the, oops, this zoom doesn't work. I hope you can see it. So if you go, let me try it like this it works. So if you go on the On Code Design account and you go to the code design training, then you will find this repository, and this is the folder that we are looking at, Inter-Process Communication, Trading App. And then over here, if you look to the tags that we are going to go through are the ones that start with IPC, from Inter-Process Communication. Okay, now let's look at how it looks in Visual Studio. So first I'm going to demo the end result. The demo which I said in the beginning, sometimes it looks a bit magical. And one of the things that I want to show you first is the structure that we have. So we can see here that we have two folders, the infrastructure folder and the modules. This is very common in most of the infrastructures that I create in the projects that I design. And I want to have in the infrastructure the place where I write the code that has nothing to do with the features. That's feature agnostic. And then into the modules, I will put code that implements the business flows. So it's a bit more close to the features. And for this demo, we have a portfolio, we have quotations, we have sales. And each of them has one assembly. And then we have the contracts assembly. Now, in this demo, there is just one contracts assembly. You could look at it as they were system contracts. In a more complex project, you might want to have more contract assemblies, maybe one for each service, and then you could also achieve some contract ownership by placing the contracts to each service. But to be easier, in the demo, we only have one. And then I have a few hosts over here, the console host and the console UI. The console UI is just a simulation of a fat client, which helps us to advance through the demo. So let me show you how the deployment looks. I hope you can see this. So over here is how the repository looks on my disk. I will just delete this bin folder from here and go back to Visual Studio and rebuild everything. Okay, I think it was rebuilt, and the bin folder is created again. And now, if we zoom on it, there are two folders. The debug, that's actually the output of all of my builds. So in my Visual Studio solution, you have seen there are different projects. I configured them so they all output their binaries after they are compiled in the same folder, into this debug folder. And the deploy is a simulation of different deployment configurations. So I have some post-build events which run some bat files, some scripts that copy the DLLs into different deployment configurations. And for the first demo, what we are interested in are these three folders: the portfolio, the quotation, and the sales. So basically, we have one folder which only has the portfolio services, one folder which only has the quotation services, one folder for the orders service, which belongs to the sales module. And then I have here small bat file, which just runs them all. So I will start this guy. And this one opens 3 consoles. OK. I will arrange them a little bit so you can see them better. Let's see. I put them like this. So we have the quotations, we have the sales, and we have the portfolio. Now, each console is actually the same process, and it logs some information. It says, OK, there is a web server at this port. So it says which is the address where the web server is listening for requests. I implemented a small web server into the console using a web API in .NET. And then it also says what module it has loaded. So the first one loads the portfolio module. The second one loads the sales module. And the third one loads the console module. And each of them also load a proxy module, which will be used to forward the calls through REST among them. OK, and now we can bring in Postman and send some requests to these guys. And the first request we could do is to the portfolio. Let's open this one. So basically, this one calls, the path /API /portfolio get value. And if I run it, we see here we have logged into the console that we received one request. The request came from Postman, and it returned 200. And this happened to the portfolio module. But we've also seen down here that the quotation module received a call. And if we look into it, we see that the call came from a service proxy with this ID, which corresponds to the same ID from the portfolio. So what happened is that when we called the portfolio from Postman, portfolio needed the quotation, and it made an inter-process call through REST for the quotation. And the same will happen if we make a call towards the sales module. So I'm just going to open these consoles here so we can see them. Moving to Postman, and let's make a post call this time to place an order, a sale limit order. So I'm issuing the call. I get 200 in Postman. And then if I look to the consoles, I see the call coming here from Postman for the sales. And again, the quotation has received a call from a proxy, which has the same ID from the sales module. So basically, this shows us that the call indeed came from here. So we have inter-process communication between our 3 services. And now let's assume that we want to optimize the communication between the sales module and the quotation module by copying the quotation into the same deployment configuration of the sales. So what we do, I'm going to close the sales console. The others remain open. I'm coming back on the disk, and I go into the sales folder. This is where the sales console is started from. And I'm going to go here into the quotation. I'm searching for the quotation services. Oh, oops. I have a zoom-in tool, which if I use it, so it also shows my cursor doesn't work that well. That's why we got the black screen from time to time. Sorry about that. So I'm copying the quotation services from here into the sales deployment. So just hitting F5. I don't recompile anything. And now in this folder, I have, as you can see, these 2 DLLs. quotation services and sales services. I'm just going to restart the console. And now the console says, hey, I loaded 2 modules, the quotations and the sales. And if I come back and I repeat from Postman the same call, the one that goes to the sales, I got it logged over here, but the quotation which remained hosted in the other process didn't get any call. So now the sales and the quotation had an in-process communication without changing anything. So this is like the end result of our demo. So let's see how this was built from step by step. If you have any questions until this point. No questions? Good.
We have a question.
Thanks. Maybe I didn't get something right, but why did you have to copy your service?
Why did I have to copy the
wouldn't
the
it
DLL
be possible to do it without
the
the need to copy?
Without what?
Without the need to copy something.
Without the need, yeah. So basically what I simulated with that copy was a different deployment configuration. So first, I started with having each of those 3 services deployed in their own folder. And then I wanted to take the quotation and add it in the same folder with the sales. And for me, it was easier just to copy the DLL to simulate this deployment configuration. In a production environment, you would have maybe a Docker file which just puts everything as you want it on that Docker image. Or you would have some pipelines that would deploy more services in the same box. But here, just for the demo purposes, I just copied the DLL, and I did a copy just to be more visible and explicit that I don't recompile the code. So the code was built only once, and then I just copied the binaries.
Okay, I see. Thanks.
Okay, other questions?
There's one more.
In real-world applications, different services might have different versions or amount of dependencies. How do you manage copying a service by DLL if the dependencies are different from each other?
Yeah, so the question is more like if you have different versions of the contracts, of the APIs, right?
No.
No, I didn't understand the right.
If the quotation service and the sales service depended on different versions of nuggets instead of using the same nuggets. How do you manage dependencies on third-party environments in this case?
Okay, so each of the service will have to manage its own dependencies. And if you can build it and run it on a deployment which is distributed, then it will bring all of dependencies in one place. And then you could just take 2 services, what we have the sales and the quotations, put them together with each of them, with the dependencies of each in the same folder, and then each of them would load what it needs. Now, you might have some conflicts because the names of those binaries could be the same. And over here, you need probably to have a more complicated structures in the folders. So you might want to have a separated folder for each service and then somehow to know how to load them. And in a more complex project, you need to do this. You need to have a convention on which is the folder of each of your services when you're having a deployment in the same place.
Thank you.
There's one more question on Slido. Can we consider changes on front end as a first step towards modular approach? If a team needs to deliver a modern UI in the near future, while also needs to move to a modular approach, how we can handle this efficiently?
If the team needs to deliver a modern user interface. So I'm not sure if I completely understand this. So I guess the question comes from the direction if how could you have in the front end the same separation, if I'm getting it right. And basically, if you would have like a fat client, like a desktop application, then the same technique can be applied. You could have a modular system on the front-end application as well, and then you have a structure and only communication through contracts, but over there you don't need this distributed deployment. If you would have a client, let's imagine we have a web client, something built in Angular, then that one would just require to call some REST APIs, and it's less relevant how the backend is being deployed, whether it's a monolith or it's a distributed system, as long as you have some way of identifying the address where that API is being hosted. So you might need some service discovery to know the address of your endpoints that you're going to call. I hope I answered this one. Okay.
Thank you for the questions.
So let's move a bit towards the coding part. So we are going to have different stages in this demo. And first, we are going to build this console UI. And basically, we are going to see this case in which we have those three services hosted in the same process. And this is just an intermediate step. So we can have a small user interface, and we can see that the quotation service is being called, the portfolio service is being called, the order service is being called, and we have all the communication between them. This would be like the first step. And the benefit of doing it like this is that you have a structure behind that keeps a separation among these services. So again, the dependencies are only through contracts. And then the next stage would be to do the same for the backend, for the console host. So we are going to have like a fat client, which is the console UI, and a fat backend, but they will not communicate one with the other. When we are going to call through the console any of these services, it's going to be an in-process communication because everything is available there. When we are going to do some calls from Postman, we are going to have, again, an in-process communication. The next step we are going to see is how we have a communication between these two consoles through REST. We can have it like this or like this. And then towards the end, we are going to go to the end stage, which I just demoed. So these are going to be the steps that we are going to go through. And yeah, I will come back to these slides and I will guide you step by step. I also have some notes over here which will help me to switch to the correct tags in the Git. Okay, let's go back to Visual Studio now. And I will close all the consoles from the previous demo. And I will just go to the initial state, so to quite clear Visual Studio solution. Not going to start from the very basic, but close to that. Okay, so again, we start with this structure. I'm not sure if it's visible for everybody, so I'll try to zoom it a bit. So the starting point is an empty folder in the infrastructure, and for each of the modules, we only have an empty console. So this doesn't have anything in it. And we have the contracts, and we have the console host. Now, one thing that I usually do is to look at this dependency diagram. So I can generate this from code. There are many tools in many languages which can do this. I use ReSharper. And what I want here is to, as I evolve the demo, as I evolve the project, is to keep a structure like this, meaning no dependencies between my modules. They should only depend through the contracts. Because I don't have yet code, this is easy to be achieved at this point, because there is no code, there are no references. Now, what I have in this step already written are some contracts. And I have a contract for the quotation service. As you can see, it's just a plain interface. It has two functions: gather quotations by the exchange instrument, from, to, or by the security code. And it returns a DTO, which is, again, very simple. One thing to point here is that you need to be careful. So these types, these data structures are easy to be serializable on the, for the protocol, for the communication protocol that you are using. In this demo, we are using REST, so these need to be easy transformed to JSON. If you would use gRPC, then they should be serializable through the protobuf. If you're using a message bus, then you need to see what's the needs over there. In general, you want this to be very simple and concrete types. I mean, I prefer to use here an array rather than an iList, which is an abstract, which is an interface. So this is one thing to keep in mind. And this being a contracts assembly, as I said, no logic is allowed here. Now let's move to the second step, which implements a little bit the contract that we have. I'll go directly to step number 3. Okay, and over here, let's see. So over here, I added an implementation for the quotation service, the contract we already looked at. And the implementation, this being just a demo, it's, of course, very dummy. I have some quotation hard-coded here in an array, and then the functions just filter them. Nothing special. And I've written here another contract for the orders service, and the implementations of the order service is basically, again, quite trivial. What's important to outline here is that the order service class, which implements the interface, takes a dependency on the contract. So you're not allowed here to take dependencies on concrete implementations. So it receives through dependency injection, it expects the dependency injection reference to this interface, iQuotation service, and it's going to use it to get all the quotations, and then it will go through the quotations, see if the ask price of each quotation is bigger than the select price. This is for the selling limit order, and if yes, it adds it or not. The important thing, again, is to depend only on contracts. And now I can move a step forward and just bring the other contract implementation, including the contract and the implementation. I need to reopen the solution. Okay, so now I have an implementation for the portfolio service, sorry, the contract, with its implementation, again, a dependency towards the quotation service. Now if I if I generate again the project dependency, we have some dependencies, but the rule is, again, followed. So no dependencies among the implementations, they only depend through the contracts. And at this point, everything is quite disconnected. I have some interfaces and some implementation, nothing specific at this point. But I really want to keep this structure as it is. And basically, what I want to avoid are references like this. And each time you would want to create something like this, it would be very visible. For instance, if you would go into the, let's say, the implementation of this contract, the order service. And you would say, you would try to make a dependency towards the class, not towards the interface. Now, ReSharper at this point, I don't think it even suggests to make to use that class. And the reason is that the quotation service implementation, which is placed here into the quotation folder part of the modules, this is an internal class. So this is internal on purpose. It's a way to hide the implementations. Now, let's say you come here and you make it public. And now if I go back, ReSharper would probably say add a reference to it. And if I do that and I would regenerate my diagram, I would get here a reference, which is against the rules that I have in the project. And in large projects, what I usually do, it a lot depends on the size of the team and of the seniority of the team, is that I enforce these checks in continuous integration. There are multiple ways you can do this. If you're using Visual Studio and you're a Microsoft tech guy, you would probably use Visual Studio Architects Enterprise Edition, which has architecture tools, and you're able in there to draw a diagram with the dependencies among your modules. And then when the entire solution is being built, Visual Studio automatically checks the dependencies from the code with what you drew in that diagram. You could just write some simple tests in code that check the references using some reflection, and then you run those in continuous integration. But most of the cases, I don't automate this because when I do a review on the implementation, I can just generate the diagram, and this is very visible. It doesn't happen then every time someone adds a references among the projects, and when a reference is being added, you can see that in a code review very easily. Okay, I will just reset this. And there's another point here to make. So as I was saying, everything is very disconnected now. And if I look now to the main function, to the only executable file which I have, which is this console host, there is nothing in here. And normally, what I need now to do is to configure the dependency injection container. So I would write something like, it highly depends what container you would use. But in general, the code would look like something like this. Register, here we go, the Copilot already knows. So I would say something like this. Register a pair of interface and implementation. This is what typically gets written on a main function. So before any project is ready to receive, any service is ready to receive requests, there is the configuration part that usually runs on the main, and you have this configuration of your dependency injection container. Now, if you write this code, then it implies, coming back to this diagram, it implies that your console host takes a dependency on the contracts. We are fine with that. That's why I used a green arrow. But it also needs to take a dependency on the implementations, because otherwise that code from the main would not compile. And if I do this, I can no longer achieve that flexibility at deploy time, because now the host is not generic. The host needs to have all of those DLLs deployed. Actually, when you build it, they will be dragged over there. And this will happen in Java or any other technology. So that's why we need type discovery, which is the third pillar from my slide. So we need a mechanism which configures the dependency injection based on some conventions, annotations, in a declarative manner, not an imperative one as this code would be. So to do that, what I'm going to use in this demo is a simple library we built at iQuark many years ago. It's called AppBoot. Again, it's available on GitHub. So, sorry, wrong Zoom. This one. So GitHub iQuark AppBoot. And this one doesn't do anything fancy, but what it allows you to do is to register is to declare basically in this manner the pair between interface and implementation. So basically what it provides is this attribute service, which says for any class that I'm decorating, that class should be registered as the implementation for the interface that I'm specifying in here. And then what the app boot does is when on the main function, it scans all the assemblies and all the types from those assemblies and looks for this attribute and does the correct configuration of the dependency injection container. We can have a look. I think I have the time to do that as well. We can have a look on the code from app boot, because I said in the beginning, I promised you there is no magic in here. So I'm bringing in at this point another library in the demo, but it's very simple. We can have a look through the code. So the app boot basically has this class bootstrapper, which receives a set of assemblies. It keeps it over here, and then it has a list of registration behaviors. And a registration behavior, it's very trivial. It has one function which receives a type, and it returns what should be registered into the container for this type, if anything. The service info is the interface, the implementation, contract name, and lifetime. It's basically an abstraction of a dependency injection container. And actually, the way we've written it is it abstracts the dependency injection container, so we could plug in any dependency injection container you would want to use. So on the run function of this bootstrapper class, there is some configuration with the container, and then there is this register services, which basically is 2 for loops. One goes through all the types from all the assemblies, and for each of the type is being passed to all the behaviors that have been registered. And that's pretty much it. From each behavior, the service infos are being received. They are being added to this catalog, and then from the catalog, they go to the container. Quite trivial. OK. Now, let's go back to our demo and plug in the app boot. So I'm going to reset my, sorry about that. It's a small table over here. I'm going to reset my, my changes. And let's go to next step. Here we go. Basically, in this step, we didn't add any code, but what we did, we added the app boot as NuGet dependency. So all of our projects received this one, except the console host, which, if I look at it, has, besides the app boot itself, it also received the appboot.unity, because in this demo, I'm using Unity dependency injection container. That's the only thing which is special. OK, and now I can move to the next step to actually configure and use the app boot. OK. Here we go. So in this step, we added this console UI. So, sorry, the wrong zoom. So I have the console host and the console UI. And the console UI, I will mark it as the startup project. The console UI, as I said in the beginning, is mainly to help me to advance through the demo. So I need a place to easily execute the calling of those services before I have the REST infrastructure in place. OK, and what it does, it shows some messages on the screen, hello, and then it bootstraps. It does the setup of the application boot, and then it makes a call to the portfolio. OK, let's take them one by one. So setting up the application boot. Basically, the first thing that I need to pass to the bootstrapper, as you've seen, is the list of assemblies. So these are the assemblies that build up this deployment configuration, that build up my application. And in our demo is basically from the executable folder, I take all the DLLs, and I filter them so they start with contracts, portfolio quotation, or sales. There is no use to scan the DLLs that come from .NET Framework or stuff like that, third-party assemblies. I'm just scanning these to look for the service attribute. So this is what happens over here. And then display portfolio value. It gets a reference to the portfolio service, and it just makes a call to it. And if I run this at this point, it crashes by saying that it doesn't find something into the dependency injection container. And this message is a bit old from a previous test that I did. I will just rebuild everything and try again. OK, because I would expect to see over here as it is. It doesn't find a reference to the portfolio service. And the error comes over here when I'm trying to get from the service locator a reference to the portfolio service. It doesn't find it. And the reason that happens is that at this stage, at this point, if I go to the portfolio service implementation, I didn't use yet the service attribute. So I need to add it here. Like this. And then the portfolio service also will need a quotation service to be injected through dependency injection. So I'd better come here and decorate this with the service. OK, the Copilot already learned about iPboot, so it's doing the stuff for me. And now if I rebuild it, OK, I'm not sure if I did. I'll try it again. OK, and now if I run it, the call went through. So I already have the portfolio value. At this point, we are in this deployment configuration, so everything happens in process. There is nothing more than dependency injection until now, but supported by that structure, so we only depend on contracts. We don't have dependencies between the modules and so on. It's basically a support for a modular monolith, if you want. OK. And let's have a look. Let's complete this. So I'll go to this sub step. First, I need to reset. And then I'm coming here. So basically, in this step, I'm adding the service attribute everywhere. And I just wanted to generate once again the dependency diagram from the code. So it looks as we expected it. No references among the modules, and everything depends only on contracts. The modules depend on the contracts either to implement them or to consume them, and the UI, again, depends on the contracts only. So the next step would be to go a bit further. So coming back to the slides to follow this a little bit easier, we are more or less at this point. We can do the same for the backend, for the console host, meaning adding the application boot. But it would be nice to advance a little bit and have the call through REST API. Oh yeah, one more point, which might be relevant, is that at this moment, the console UI, it's basically, if we look over here, all these modules are not hard-coded. So I mean, if I am taking out one of them or I add a new one, it will be plugged in and it will work as expected. Okay, let's move to the to add some REST API to the console host. That's step number 7. Here we go. So now we can we added some code here in the console into the console host. Let's zoom it a bit, and let's browse it. So first on the main, I'm just hosting a web application. Doesn't do much. Then I'm configuring the routes. It will use a controller. It will use an action. And then we have here the same configuration of the application boot as we did it for the console UI. And again, it's adding these modules. And another thing that we need here is to have some controllers. So into the console host, I added some controllers, and over here, if we look at one of them, for instance, the orders controller, basically what it does, this is the way you expose as a REST endpoint one of the contracts, and this is for the orders service. So it expects to receive an implementation of the contract, and then the REST call through the web API framework, it will end up in this function, and basically it will just forward the call to the real service which it received. Now, for this demo, I have hard-coded here the controllers. In a project which is in production, you might want to have this like a truly generic host, meaning to have a controller which is able to host any contract, and then based on some conventions to detect which is the function. The way I did it here is, for instance, if you don't have an implementation for the orders service, when these requests come, the REST request comes, it will just crash. So probably another way of doing it, if you do not want to invest in making a generic controller, you could inject here some dummy proxies for all the services, all the contracts that you have, which just say this wasn't deployed, and then you have some smarter error handling, which will return a 404 rather than an exception. But for this demo, it just assumes if a call comes to this deployment for the orders, there will be a service to satisfy it. Okay, and good. So we have some the REST services. I think we can run this. So let's run the backend, and I will make this as a startup project. So now it says that it is running at this port, and it loaded everything. Okay, and now if I come to Postman and I send it some calls, let's say get portfolio or get quotation, that's the easiest. It will just work. So basically, we have done the connection to we have done the work to expose as REST endpoints the functions from our controller. So we are at this point. Sorry, at this one. Okay, let's see what else. So the next step would be to connect the UI and the backend. And for that, we need some proxies which complete the picture. So basically, when you're calling, when you're having a call over here in the UI, you want to have a proxy that forwards the call through the REST into the console. And to do that, we need to implement the proxies. And let's just do that. So that would be step number 8. Here we go. Okay. So if we look here into the infrastructure, we added the proxies project, and basically at this point, we only have some helpers in here. I think I need to advance it a little bit to also have some implementations for the proxies. Let's go to this one. Okay. So coming back to the proxies, I have one proxy for each of my services. I have an orders service proxy, which implements the same contract, and this time it will just use an HTTP client. It will build based on some conventions the URL path, so adding as into the query string the parameters, and it will just make the call. And the same I have for the portfolio proxy and so on. And now to run this, we can do it through the console UI. Actually, I think I'm going to start both, the host and the UI. So I will first I will build everything. Here we go. Okay, now I'm going to start the host. Okay, and I'm also going to start the UI. And I'll put them, actually, I didn't need to put them side by side. So as you can see, when the UI started, the first thing it did was a call to the portfolio service. It returned 27 pounds for my portfolio value. And we had a call to the quotation service on the backend. So this was a call through the proxy, which we just added. And we can check that because we have the same IDs over here. And then if I move forward and I say, OK, give me all the quotation for New York Stock Exchange, this crashes because I have some bad request. But again, the call went through REST. So I'm at the point of being able to call through REST from the console UI, the console host. Now, if we look a bit more carefully into the console UI, over here, you can see that we are loading in the same process the proxies and the current implementations for all. So it's not really deterministic which will be used. In this run, the proxies have been used. So when I called, when it started the UI, it basically said display portfolio value. And in this function, it got a reference to the portfolio service. And then the portfolio service by itself, if I go to its implementation, it got a reference to the quotation service. It's not deterministic whether this is going to be a proxy, which will forward the call through REST, or is going to be the real implementation. Because it just matters on how the application boot on this one. Over here, it only matters how the application boot, in which order it loads the DLLs. So if it gets the DLLs from the disk in a way that first it registers the real implementations into the container, and then it finds the proxies, the configuration of the proxies will overwrite the real implementation, or it can be the other way around. And this is happening because at this point, we are decorating with a service attribute both implementations, the proxy and the real one. Let's have a look on If I look for the, let's say, for the quotation service, if I look for this one, it has now two implementations. The real implementation, which is decorated as a service, but it also has the proxy, which is again decorated as a service. So it doesn't really, we can't really know which one will be used. So we need a step further to make a distinction between these two. So basically, we would like to have here a proxy, a way to say this is actually a proxy. First, so when we configure the app boot to know which one has priority. And basically, this is the only step that we still have to do. Let's see. Okay. Okay. Maybe I still have some changes, so I'll just reset them. Okay. So what we did in this step was to add an extension to the application boot, and that extension adds the service registration behavior. So here into the infrastructure, I added an app bootx, an extension to the application boot, which has these two classes, a service proxy attribute, which is very similar with the service attribute that we had before. And basically, it just receives a type through the constructor. And then it has a service proxy registration behavior. And the service proxy registration behavior, basically, it will look for the service attribute as a decoration for the type, and it will return it as is. And now, let's see how this gets used. So if I go to the main function for the console UI, now I add two registration behaviors. And here, the way we built the application boot is we did it in a way that it matters which one you add first. So always the last ones will override the first ones. So basically, we say for the application boot, OK, we create the bootstrapper, we give all the assemblies. We say you should use Unity, and then we say add the service proxy registration behavior, add the service registration behavior, and then we call the run. Now if we go back to the run just to have another look on what happens over here in the register services. So the call comes here, then it goes to register services, and over here I'm using this registration catalog. And the reason I need to have a smarter catalog is just to add these registrations with a priority. So basically, now it doesn't matter in which order I will find the types from my assemblies. I will just go through the behaviors in the order that they were added, and each time I add a service info registration, I will add the priority of it. And then this registration catalog orders them by this priority. So when I'm iterating the catalog, I will get the registrations that I need to put in the dependency injection in the correct order. And coming back to my configuration, because I added the proxies first, this will be overwritten by the real implementations. So basically now, the assumption is that in all of my deployments, I will have the proxies available. So I will put in my container, my dependency injection proxies. So it means all the calls that I receive, I will be able to forward them over the wire. But if I get a real implementation in there, I will use the real implementation. And this is how this dual behavior between my deployments actually works. And we can do the same for the console host. So at this point, it's only done for the user interface. I can do the same for the console host as well. Yeah. Okay, let's move to the next step. Okay. So now, if I'm looking to the console host, this one, it also uses the service proxy registration behavior. And now if I would rebuild everything, then I can repeat the demo that we started with. So I have everything deployed in its own process. And now I can just make Postman calls to them, and I will have an inter-process communication. Get quotation, this one has no dependencies. Oh, sorry, I need to change the addresses. So this one has no dependencies, that's why I'm just getting the call from Postman. But if I go and I do a call to the sales order, then I get the call here into the sales, and then the dependent call into the quotation. And I can see it's coming from here because this should match. So this is, yeah, this is the sales, and here we have the match. Actually, it's like this. The sales calls the quotation. This is the quotation. And now I could go into the sales and, or actually I could go into the, into the sales and add also the quotation, and I will have just an in-process communication as we did in the beginning. Oh, sorry, into the sales. So I got this one logged, and nothing new got logged over here. Okay, so we completed the circle, and we've seen how everything got built. Now, in this demo, what I didn't do, and again, only because it is a demo, is that when I have this in-process call, I'm actually using the real implementation in there, which is not going to be a good idea when you do it in production. Because when you're calling a contract in a modular system, or from the order service perspective, in this kind of setup, you would expect that the implementation to be somewhere away, somewhere over the wire. So if something breaks in that implementation, for instance, an index out of bounds, and null pointer exception or something like that, if it's a separated deployment, you would get, if it's REST, internal server error of 500. Then you move to an in-process communication deployment and call the same service, and you get an index out of bounds. So the contract is not consistent if you switch the types of deployment. And this is not good. So what you need to do in production is to have another set of proxies that will forward the call in the same process. And those proxies will wrap the real implementation, doing a better error handling and maybe logging and telemetry and stuff like that. So you should always use proxies for this to work in production. Actually, this is how we do it in production. But for the demo, I just took the shorter route. Good. If you have questions or comments, or you want me to go into more detail on any side of this,
Any questions from the audience, or shall we check the Slido? I guess then the Slido. So what about timeouts and retries in the HTTP proxy?
Yeah, so it's exactly the point that I was making at the end. So you should consider as you would call the service through REST, and then if you have another set of proxies, that's the place where you could handle this. Now, if this is about have some mechanism which will basically retry for a couple of times every call, then you need to do that on the client side, no matter if you're having a remote implementation of the service or a local one. So that's more part of the client on the way you're making the call on the client side. So I think there are two sides on this question.
Thanks.
Sure.
Next one then, the DLLs are loaded at runtime. How much overhead does it take? And how would you deploy this application to production? I guess you also addressed this in the end somewhat.
Yeah, it's a very good question. Actually, there are two. So how much time it takes to load the DLLs at runtime? What everything happens, the load of the DLLs happen actually on the main function. So that's in a distributed application, that's the warm-up of the process of the system. So actually, it doesn't really matter because if you would have a distributed system and it takes a lot for it to be configured and to be able to receive requests, then you just need to implement some warm-up mechanism. And that means after you finish the deployment, you just fire some requests, or you wait for a longer time until it gets ready to receive requests, real requests. If this would be done in a desktop application, so this is a technique you could use to have modular monolith on the front end, then indeed this can become a problem because you would have, imagine like you would have a backend, a back office application on desktop, on Windows or on the phone. You would open the screen and then you'd have to wait for everything to get loaded. So for that, you would need to have some optimizations in there. And you can do that on a desktop. You can have the DLLs preloaded, and basically you're pretty much the same as you would load them directly or dynamically. So it depends on the context. And there was another side of the question.
I guess, how would you deploy it in production, like this application?
How would I deploy this into production? I think that was the other part of the question. So here it depends on how is the production environment? How does it look like? If it would be, for instance, containers orchestrated with Docker, let's say, then I would need to have some Docker files, some build files for each of my deployment configuration. And in that Docker file, I would write, I would actually copy the binaries which were built into that Docker image. And then the way you put the Docker images on Kubernetes is the same. It's not really impacted by this design. If you would deploy, for instance, without Docker, you just need to ship the binaries to a cloud service, then it depends on your pipeline. But you need to have some pipelines which know, okay, for this deployment configuration, I need to copy these DLLs, and that's it. And you also need to take care of the addresses. So ideally, you should have a service discovery which knows to give you the address of each service based on a name. So in our case, we only had 3 services: portfolio, quotations, and sales. Each of them had an address. Maybe you've seen me here in Postman that I was changing these configurations. So basically, for this demo, I had some hard-coded addresses for each of them, so things would work for the demo. In production, ideally, you should have a service discovery service which is able to give you the address based on a name, and then you just change that that registry. It's basically like a DNS for production.
Thank you. Any other questions? Actually, have one extra. There's nothing. So you mentioned preloading DLLs. How would that look like? I'm not that familiar with Windows anymore, so I'm just interested.
Can you please repeat it?
So you mentioned you would preload the DLLs for when the question was about how much runtime overhead it adds.
So that I would do that only for the case when I'm having a front end built with this configuration. Because if I'm on the server side, then I'm no longer having that. I mean, I'm not bothered by the fact that I need to load the DLLs dynamically. It is just some overhead that I have until my service is ready. So it's just warm up, and that's really not shouldn't be an issue.
Thank you. Thank you. Then I think that these were the questions. Then that's all?
Yeah.
Okay.
That's all from my
then,
side. Thank you.
Please, thank you for sticking around, and give a round of applause for Florin.